Question 5 is a hypothesis test question. So we've got some information about what we want. So Nina believes the proportion of visitors to this website who make a purchase is less than 0.03, and they've got some data to test it. Now what they've done is they've counted the number of visits until a purchase is made. So this means we're looking at a geometric distribution, and she wants to test the proportion. So our null hypothesis is that the proportion of visitors, so the probability of a visitor making a purchase, is 0.03. So our alternative is that Nina believes it's less than 0.03. Right, so if X is our number of visits to the website until a purchase is made, then under H0, X comes from a geometric distribution with P is 0.03. Now what they want, we want a 5% level of significance, and we want to find the critical region for this test. Now you need to remember, for a geometric, the probability of X being greater than or equal to a value is 1 minus P to the X minus 1. That is not in your formula book. Right, so that's one of those things you need to learn. Okay, so we want a 5% level of significance. So I'm going to let 1 minus P to the X minus 1 equal 0.05. You could do this as an inequality, so you'd say it's got to be less than 0.05, but I find it easier to make it equal to, find the value for our X, and then I'm just going to change that to N, is going to be what I'm finding. Find our value for N and then work out which way we need to go. Okay. So 1 minus 0.03 is 1 equals 0.05. If you then solve that, we can solve that using logs. Remember, your calculator could do log to any base. So I get N is 99.35. So that would be the point if N could be a non-integer, at which the probability of being greater than it would be 0.05. So if I think about this logically, actually our value has to be an integer for a critical region. If I do N is 99, I'm going to get a probability greater than 0.05, because the higher N gets, the more the probability is going to decrease. So that means N is actually 100. If you're not sure, just try subbing in 99 and 100 into your formula and see which one comes out as above or below 5%. So our critical region is X is greater than or equal to 100. Remember, your critical region isn't a probability, it's a value for X, a range of values for X. Right, so there's our critical region. Now I want my actual significance, so that's the actual probability of being greater than or equal to 100. So to do that, I'm going to do 1 minus 0.03 and then put in my 100 minus 1. So whoops, 0.490. Okay, so your actual significance is just the actual probability, which, unless told otherwise, should be less than the significance level, unless they told you to go as close as possible. Okay, so the 94th visitor to the website was the first person to make a purchase in this case. Let's just move that to one side. Okay, so what can we say here? Well, our critical region was X is greater than or equal to 100, and 94 is less than 100, so not in critical region. You always, in stats, if you're comparing numbers, you should state the obvious. So they like to see you actually write down which numbers you are comparing. Right, so it's not in a critical region, therefore do not reject H0. Now we can never be certain when we do a hypothesis test, so I can't say the probability is 0.03, but we can say there is insufficient evidence. Okay, so you'd either say there is evidence or there is not enough evidence at the 5% level. That, and then we're going to put this in context of the question. So the proportion of visitors making a purchase is less than 0.03. Okay. You've just got to do a correct conclusion in context. I think another alternative would be to say there's not enough evidence to support Nina's belief.